Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today, we are conquering LeetCode 909, the Snakes and Ladders Challenge. This is the ultimate test of your breadth-first search intuition. Let us look at the problem statement. We are given an n by n board, numbered from 1 to n squared in a Boustrophedon style. That means the rows alternate directions, starting from the bottom left corner. We start at square 1, and our goal is to reach the final square with the minimum number of dice rolls. From any square, we can roll a 6-sided die to move forward 1 to 6 steps. If we land on a square with a ladder or a snake, we must take it to the destination. But remember, we only take a transport once per roll. Think of it like a quantum speedrunner, attempting to set a world record in a teleporting maze. At every step, our runner splits into 6 different versions of themselves, each exploring a different dice roll. If a version hits a ladder, they instantly jump ahead. If they hit a snake, they slide back. Because all these versions move simultaneously, the first one to reach the finish line is guaranteed to have taken the shortest path. This is exactly how breadth-first search works. Our strategy is to treat the board as an unweighted graph. Each square is a node, and each dice roll is an edge. Since we want the shortest path, BFS is our golden rule. We will use a queue to track our current squares, and a visited set to ensure we never waste time repeating a path. Let us dive into the dry run. Look at the screen. We have a 6x6 board. We start at square 1, at the bottom left. Our queue begins with square 1, and our moves counter is 0. In our first roll, we can land on squares 2 through 7. Notice square 2 has a ladder to 15. So our queue now holds these potential destinations. We mark them all as visited. For our second roll, we process square 15. A roll of 2 takes us to square 17. From 17, we roll again and land on 35, which is a ladder to the final square 36. Found it! In just 4 rolls, our quantum speedrunner has reached the goal. The minimum moves required is 4. Now, let us look at the Python code. We start by calculating the board size, n. We need a helper function, labeled to POS, to convert a square number into matrix coordinates. We handle the alternating row direction using a simple check on the row parity. Next, we initialize our BFS. We put square 1 into our queue, along with a move count of 0. We use a set called visited to keep track of where we have been. Inside the loop, we pop the current square in moves. We simulate all 6 dice rolls. For each next square, we check the board. If it is not -1, we update our destination. If that destination is our target, n squared, we return moves +1. Otherwise, if we haven't visited it yet, we add it to the queue. If the queue becomes empty and we never hit the target, we return -1. Looking at the complexity, the time complexity is O of n squared, where n is the board dimension. We visit each square at most once. The space complexity is also O of n squared, to store our visited set in the BFS queue. And that is Snakes and Ladders, mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.